Welcome to Innovation Pulse, your quick, no-nonsense update on the latest in AI. First, we will cover the latest news. Anthropic unveils advanced AI models, fierce competition for Silicon Valley talent, Jony and Sam Altman's AI device, and Google's upgraded Canvas platform. After this, we'll dive deep into Google DeepMind's revolutionary Alpha Evolve system. Today, we're unveiling Claude Opus 4 and Claude Sonnet 4, the next generation of Claude models. Claude Opus 4 is the best coding model globally, excelling in complex long-running tasks, while Claude Sonnet 4 improves on its predecessor with advanced coding and reasoning capabilities. Both models can now use tools like web search during extended thinking, enhancing their responses. They support parallel tool execution and improved memory functions, storing key facts to build knowledge over time. Claude Code, now widely available, integrates into IDEs like VS Code and JetBrains, offering seamless coding collaboration. Additionally, new API capabilities enhance developers' ability to build robust AI agents. These models, available on the Anthropic API, Amazon Bedrock, and Google Cloud's Vertex AI, represent a significant leap in AI, supporting diverse applications from research to everyday tasks. Pricing remains consistent with previous models. For now, let's focus on the recruitment strategies. In Silicon Valley, the race for AI dominance is intensifying, focusing on superstar researchers. Since the launch of ChatGPT in 2022, recruiting top AI talent has become fiercely competitive. Companies like OpenAI and Google offer massive compensation packages, sometimes over $10 million annually, to attract and retain these researchers. The scarcity of elite AI talent, often called 10,000 times engineers, has led to innovative hiring strategies, including using sports data analysis to find promising candidates. Despite lucrative offers, some researchers, like Noam Brown, prioritize meaningful work over financial gain. The recent departure of OpenAI's Mira Murati to start her own AI venture has further heated the talent competition. As AI rapidly evolves, companies are seeking talent from diverse fields, such as theoretical physics and quantum computing, to fuel advancements. Details are emerging about Jony and Sam Altman's new AI device. Analyst Ming-Chi Kuo suggests it will be slightly larger than Humane's AI pin, but as compact and elegant as an iPod Shuffle. The device could be worn around the neck and might lack a display, instead featuring built-in cameras and microphones for environmental detection. It may connect to smartphones and PCs for computing and display functions. This aligns with reports indicating the device will be aware of users' surroundings, but isn't likely to be a pair of glasses. Recently, OpenAI announced purchasing IVE's AI hardware company, IO, for $6.5 billion. This acquisition will influence the design of OpenAI's software and hardware. IVE and Altman plan to launch their first devices in 2026. Google has upgraded its Canvas platform with the Gemini 2.5 models, transforming it into a powerful creation tool. Canvas now allows users to convert documents and code into web pages, infographics, quizzes, and podcasts in 45 languages. The standout feature, vibe coding, lets users describe ideas to generate code for apps and games without writing a single line. This makes app development accessible to anyone with an idea. During a live demo, Tulsi Doshi from Google turned a sketch into a 3D web app in minutes using Gemini. While there are some limitations, like workspace users not being able to share content, the platform promises a new way to bring digital ideas to life. This innovation aims to lower the barrier to creating software, allowing for rapid prototyping and interactive learning experiences. Join us as we discuss the new API enhancements. Anthropic has unveiled 4 new API capabilities to enhance AI agent development. a code execution tool, an MCP connector, a files API, and extended prompt caching. These features, alongside Claude Opus 4 and Sonnet 4, allow agents to execute complex code for data analysis, connect to external systems via MCP servers, and manage files efficiently. Developers can also maintain context for up to 60 minutes, cutting costs significantly. For instance, a project management AI can integrate with Asana to handle tasks, analyze progress, and maintain context using these new tools. The code execution tool enables Claude to run Python code for financial modeling, scientific computing, and more. The MCP connector simplifies external tool integration, while the Files API streamlines document handling. Extended caching reduces expenses and latency for long workflows. These tools provide a robust set for building advanced AI applications. Google recently unveiled Gemini Diffusion, its first language model that uses diffusion techniques instead of traditional auto-regressive methods. Unlike traditional models that generate text sequentially, diffusion models refine noise step by step, allowing for rapid iteration and error correction during generation. This enhances tasks like editing, particularly in math and code. The key advantage is speed, as demonstrated when tasked with building a chat app, responding at 857 tokens per second. While independent benchmarks are not yet available, Google's landing page claims it matches the performance of Gemini 2.0 Flashlight at 5 times the speed. Unlike image diffusion models, diffusion language models resemble BERT, using a transformer to predict masked tokens in parallel. This method allowed for generating sequences by gradually reducing the masked tokens, refining outputs efficiently. And now, pivot our discussion towards the main AI topic. All right, everybody, welcome back to Innovation Pulse. I'm Donna, and today we're diving into something that honestly sounds like science fiction, but is happening right now in Google's labs. We're talking about an AI system that doesn't just solve problems. It literally invents new ways to solve them.
That's right, Donna. I'm Yakov Lasker, and what we're looking at today, Google DeepMind's latest creation called AlphaEvolve. And here's the kicker. This isn't just some research project sitting in a lab somewhere. This AI has already been quietly running Google's data centers for over a year, making them more efficient. And it just broke a mathematical record that had stood since 1969.
Wait, hold up. Since 1969, we're talking about something that mathematicians have been working on for over half a century, and an AI just figured it out?
Exactly. So let me paint the picture here. You know how we've seen AI get really good at specific tasks, right? Like AlphaGo mastering the game of Go, or AlphaFold solving protein structures. Those were incredible, but they were specialists, one-trick ponies, if you will.
Right. Like having a chess grandmaster who can only play chess.
Perfect analogy. But AlphaEvolve is different. Think of it as a mathematician, computer scientist, and engineer, all rolled into one. Except it works at superhuman speed and never gets tired. The system combines Google's Gemini language models with what they call an evolutionary approach.
Okay, so break that down for me. What does evolutionary mean in this context? Are we talking about digital natural selection?
That's actually not a bad way to think about it. Here's how it works. AlphaEvolve takes a problem and generates hundreds or thousands of potential solutions. Think of these as different species of algorithms. Then it tests each one, sees which ones perform best, and uses those winners to create the next generation of solutions. The weak ones die off. The strong ones reproduce and mutate, creating even better solutions.
So it's basically running its own algorithmic survival of the fittest. That's wild. But I'm curious about the practical side. You mentioned it's already running Google's data centers?
Here's where it gets really impressive. AlphaEvolve discovered a new scheduling algorithm for something called Borg. That's Google's system for managing millions of servers worldwide. This one algorithm change freed up 0.7% of Google's total computing resources.
That doesn't sound like much.
Oh, but it is. At Google's scale, 0.7% represents hundreds of thousands of machines. We're talking about millions of dollars in efficiency gains, running continuously 24/7. It's like finding free money in the couch cushions, except the couch is the size of a small country.
Okay, now I'm paying attention. What other problems has it tackled?
This is where it gets really fun. Remember that 56-year-old mathematical record I mentioned? It involves something called matrix multiplication, basically a fundamental operation that underlies almost all of modern computing, especially AI training.
Matrix multiplication. That sounds like something from high school math class that I tried to forget.
Lay it on me. What exactly did it discover?
So back in 1969, a German mathematician named Volker Strassen figured out a clever way to multiply certain types of matrices faster than anyone thought possible. His method became the gold standard, and for 56 years, nobody could beat it. Then AlphaEvolve comes along and finds a way to do it with one fewer operation.
One fewer operation doesn't sound revolutionary.
But that's the thing about mathematics. Sometimes the smallest improvements have huge implications. When you're multiplying matrices billions of times to train AI models, that one operation saved adds up. AlphaEvolve actually used this discovery to speed up the training of Google's own Gemini models by 23% for that specific operation, which translated to a 1% overall training time reduction.
So it's literally making itself smarter, faster?
Exactly. It's optimizing the very systems that power itself. There's something almost poetic about that. But here's what really blows my mind. When they tested AlphaEvolve against DeepMind's previous specialized system called Alpha Tensor, which was built specifically for matrix multiplication, AlphaEvolve actually outperformed it. A general-purpose system beat a specialist at its own game.
That's like a decathlete beating a sprinter in the 100-meter dash. How is that even possible?
It comes down to the evolutionary approach. While Alpha Tensor was constrained by its specific training, AlphaEvolve could explore solution spaces that humans might never have thought to look at. It's not bound by our preconceptions about how problems should be solved.
This reminds me of those stories about AI finding unexpected strategies in games. Like when AlphaGo made moves that professional players thought were mistakes until they realized they were genius.
Perfect comparison. And speaking of unexpected discoveries, AlphaEvolve tackled something called the kissing number problem.
The what now?
I know. It sounds like middle school gossip, but it's actually a serious mathematical challenge. Imagine you have a sphere, and you want to surround it with as many other identical spheres as possible, all touching the center sphere, but not overlapping each other.
Okay, I can visualize that, like oranges stacked at a grocery store.
Exactly. In 2 dimensions, think circles on a flat surface. You can fit 6 circles around one central circle. In 3 dimensions, it gets more complex, and the number is 12. But as you add more dimensions, the problem becomes incredibly difficult. In 11 dimensions, the best-known answer was 592 spheres could touch the central one.
And let me guess, AlphaEvolve found 593?
Bingo! Now, that might seem like a tiny improvement, but in mathematics, proving that even one more is possible can open up entirely new areas of research. It's not just about the number, it's about the method used to find it.
So we've got data center optimization, matrix multiplication, breakthroughs, and abstract mathematical discoveries. What else has this thing been up to?
Well, it's also redesigning computer chips. AlphaEvolve proposed changes to Google's tensor processing units, their specialized AI chips. It found ways to eliminate unnecessary operations in the chip's arithmetic circuits, making them more efficient without compromising accuracy.
Hold on. So this AI is now designing the hardware that will run future AIs?
You're starting to see the bigger picture. We're looking at a system that's optimizing everything from the physical chips to the software algorithms to the data center management, creating a feedback loop of continuous improvement.
That's simultaneously exciting and a little terrifying. How does this actually work under the hood?
Great question. AlphaEvolve uses 2 different versions of Google's Gemini model working together. Gemini Flash handles the breadth, generating lots of ideas quickly. Gemini Pro provides the depth, offering more sophisticated solutions when needed. But here's the crucial part. It's not just generating random code and hoping for the best.
Right, because we know AI can hallucinate and make stuff up.
Exactly. That's where the evolutionary framework comes in. Every solution Alpha Evolve proposes gets automatically tested and scored. Can it solve the problem correctly? How fast does it run? How elegant is the solution? Only the solutions that pass these objective tests survive to the next generation.
So it's like having a ruthless editor that immediately fact-checks every idea and throws out anything that doesn't work.
Perfect analogy. And because the evaluation is automated, Alpha Evolve can test thousands of solutions in parallel, something human researchers could never do at that scale or speed.
Now I'm curious about the limitations. This sounds almost too good to be true.
You're right to be skeptical. Alpha Evolve works best on problems that can be clearly defined and automatically evaluated. It excels in domains like mathematics, computer science, and system optimization, where you can objectively measure success. But it's not going to write poetry or solve social problems that require human judgment and nuance.
Makes sense. It needs clear rules of the game to play effectively.
Exactly, and there's another important point. While Alpha Evolve is more general than previous systems, it still requires human experts to set it up properly, interpret its results, and decide which solutions to implement. It's augmenting human intelligence, not replacing it.
Speaking of humans, what does this mean for researchers and engineers? Should they be worried about job security?
Here's the thing. The researchers at DeepMind emphasize that this is about collaboration, not replacement. Matej Balog, one of the lead researchers, mentioned that traditionally you couldn't build a scientific tool and immediately see real-world impact at this scale. Alpha Evolve is freeing up human experts to focus on bigger picture problems while handling the tedious optimization work.
So it's more like having a super-powered research assistant?
Right. And Google is already planning to share this capability. They're developing a user interface and launching an early access program for academic researchers. The goal is to democratize access to this kind of algorithmic discovery.
That could be huge for universities and smaller research institutions that don't have Google's resources.
Absolutely. Imagine a graduate student being able to tackle optimization problems that would have taken months of manual work, or a researcher in materials science using Alpha Evolve to discover new algorithms for molecular simulation.
You mentioned materials science. Where else might we see this technology applied?
The researchers mentioned drug discovery as a major target. Think about it. Drug development involves massive optimization problems. Which molecular structures might work? How do you optimize for effectiveness while minimizing side effects? These are exactly the kinds of problems Alpha Evolve could help solve.
And probably much faster than traditional methods.
Exactly. We could be looking at accelerated timelines for everything from new medications to more efficient solar panels to better battery designs. Any field that relies on complex algorithms could benefit.
This feels like one of those moments where we're witnessing a fundamental shift in how science gets done.
I think you're right. We're seeing AI move from being a tool that executes human-designed solutions to one that discovers entirely new solutions. And here's the kicker. As language models continue to improve, Alpha Evolve's capabilities will grow alongside them.
It's like we're watching the early stages of AI-assisted scientific discovery becoming mainstream.
And the timing is crucial. We're facing massive challenges: climate change, energy efficiency, computational demands of AI itself, that require novel solutions. Having a system that can explore solution spaces humans might never consider could be exactly what we need.
So what's the bottom line here? What should our listeners take away from this?
The big takeaway is that we're entering an era where AI isn't just getting better at existing tasks, it's beginning to discover new ways to approach fundamental problems. Alpha Evolve represents a shift from narrow AI to more general problem-solving systems that can augment human creativity and expertise.
And the practical impact is already being felt. Google's data centers are running more efficiently, their chips are being redesigned, and mathematical problems that stumped researchers for decades are being solved.
Right. This isn't some far future concept. It's happening now, and the implications are enormous. Whether you're a researcher, an engineer, or just someone interested in how technology shapes our world, Alpha Evolve shows us what's possible when we combine human insight with AI's ability to explore vast solution spaces.
For anyone working on optimization problems or algorithmic challenges, this might be worth keeping an eye on, especially as Google rolls out broader access.
Absolutely, and even if you're not directly involved in these fields, understanding how AI is evolving, pun intended, helps us all prepare for a world where human AI collaboration becomes the norm rather than the exception.
Well, this has been fascinating, Yakov. Thanks for walking us through what might be one of the most significant AI developments we've seen this year.
Always a pleasure, Donna. The pace of innovation in this space continues to amaze me.
And to our listeners, this is exactly the kind of breakthrough that reminds us why we do this show, to catch these pivotal moments as they happen and help make sense of what they mean for all of us. Thanks for tuning in to Innovation Pulse, and until next time, keep your eyes on the future.
Because apparently, the future is busy writing its own code.
I love it. See you next time, everyone.
We've explored Anthropic's innovative AI models, enhancing coding and reasoning skills, and Google's advancements with Gemini and DeepMind's Alpha Evolve, pushing the boundaries of digital content creation and problem solving. Don't forget to like, subscribe, and share this episode with your friends and colleagues so they can also stay updated on the latest news and gain powerful insights. Stay tuned for more updates.